Hi, my name is Jamil, and today in this section we'll be looking at the real numbers system. Our objectives will be sets of real numbers, coordinate systems, appropriate viewing windows, roots, and the distance and midpoint formulas. The real number system has evolved over the course of time. It started off as the natural numbers, which included the numbers 1, 2, 3, and 4, and so on. And then came the whole numbers, which included the natural numbers as well as 0. After that, people created the integers to include the negative numbers, and then rational numbers came along to include fractions. Finally, the real numbers system was introduced. The real numbers system is a system that can be shown using a number line. Using the number line, all coordinates on the number line match up to a real number, and all real numbers match up to a location on the number line. Here you see the integers listed out on the number line, but the numbers in between the integers are included as well in the real number system. If you're to take two of these number lines and place them together and form right angles, what you'll get is a coordinate system. Here you see a two-dimensional Cartesian coordinate system. The horizontal axis is referred to as the x-axis, and the vertical axis is referred to as the y-axis. In doing it this way, the graph, or the plane, is divided into 4 regions. We call these regions quadrants. Here's the first quadrant, the second, the third, and then finally the fourth quadrant. Since the Cartesian coordinate plane extends infinitely in all directions, we can only look at a portion of it at a time. The same is true when using a graphing calculator. We call the portion of the plane that we're looking at the viewing window. We'll use the following abbreviations when looking at viewing windows. X min will stand for the minimum value of x, x max the maximum value of x. X scale is the scale on the x-axis, which refers to the distance between the tick marks. Y min is the minimum value of y. Y max is the maximum value of y. And y scale is the scale on the y-axis, or the distance between the tick marks there. Let's now go ahead and take a look at what we're going to refer to as our standard viewing window. Here we see the x min, x max by y min, y max notation, and we're going to call our standard viewing window -10 to 10 on the x-axis and -10 to 10 on the y-axis. We'll use an x scale of 1 and a y scale of 1 as well. Often throughout the text we'll be using calculators. Calculators have the ability to express our rational and irrational numbers as decimal approximations. What we need to do is take a look at how to write these decimal approximations and review the steps to rounding. Let's look at this next slide. Here we're asked to round these 3 numbers to the nearest tenth, nearest hundredth, and nearest thousandth. The first number we're given is 1.3782, and we're first asked to round to the nearest tenth. In order to do this, we've got to locate the 10th position, which is where the 3 is located, then look to the number to the right of that. If that number is 5 or greater, we'll round the 3 up to a 4. If the number is less than 5, we'll keep the number of 3. Since there's a 7 to the right of it, that's greater than 5, so we need to round the 3 up to a 4. So this number would be 1.4 when rounded to the nearest tenth. To do the nearest hundredth, we'll follow the same process, but just use the appropriate place value. So here, the 100th position, we're at the second position after the decimal, so we're looking at the number 7. And then going one space to the right of that, we have an 8, so we need to round this one up as well. So 1.37 will be rewritten as 1.38. Doing the nearest thousandth, we go to the thousandth place value, which is where the 8 is located. Look to the right of that, and we have a value of 2. That's less than 5, so there's no need to round up here. So we'll rewrite the number as 1.378. Following the same process for the next value, 201.6666, rounding this to the nearest tenth, we look at the value in the tenth spot as a 6, and then to the right of that is a 6, so we need to round up. So the nearest tenth would be 201.7. Using the nearest hundredth, again, we have a 6 in the hundredth spot, and the number to the right is a 6, so we'll round up again. So we have 201.67. And then for the nearest thousandth, 6 is in the thousandth position as well, and to the right of that we have a 6, and since that's greater than 5, we'll round this number up. So our number here is 201.667. The last value we're asked to use is 0.0819, and when asking to round this to the nearest tenth, there's a 0 in the 10th position, and to the right there's an 8, so we need to round up. So 0.08 will round up to become 0.1. Then doing the nearest hundredth, there's an 8 in the hundredth position with a 1 to the right, Again, since 1 is less than 5, we don't need to round up. So 0.0819 becomes 0.08 when we round to the nearest hundredth. And then rounding this number to the nearest thousandth, we look at the number in the thousandths position, which is the 1. And then to the right of it, we have a 9, which is greater than 5. So we'll round the 1 up to a 2. And this answer becomes 0.082. What we're going to do now is use a calculator to approximate some roots. Here in this example, we're asked to use a calculator to approximate each root to the nearest thousandth. The first one is the square root of 23. The second example is the cube root of 87. And then the third example is the fourth root of 12. So in order to do this, what we'll do is we'll take out the calculator and we'll type in the square root of 23. Okay, so the square root of 23 entered into the calculator gives us a rather long decimal number, 4.795831523, but we've been asked to round these to the nearest thousandth. So the value in the thousandths position is the 5, and after that to the right is the number 8, so we're going to round that up. So the square root of 23 will be rewritten as 4.796. Now we're going to use the calculator to compute the cube root of 87. Okay, so using that, we'll do the cube root of 87. And we get the calculator to give us the value 4.431047622. But rounding that to the nearest thousandth, we get 4.431. Now in the last example, we're asked to look at the fourth root of 12. So going to the calculator and using that to compute the fourth root of 12, the calculator gives us the answer 1.8612099718. But rounding that to the nearest thousandth, we end up with 1.861. Why don't you take a look at these next examples and try working them out on your calculator.